Praise and gratitude to the Almighty God. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the opportunity given me. My name is Jacob Letikwatil from ST Mandala Bandung. Will represent the author team to present our journal paper entitled Electrical Energy Alternative of Magnetic Field around Wire of Power Line. The background of this journal. First, electric energy crisis and consumer need. Consumers are increasing while the availability of electric is decreasing. Second, the existence of electric line with alternating electrical current generate a large magnetic field around and along the power line that stored electrical energy, but that has not been utilized. Three, there are public concerns about the danger of electromagnetic field radiation near the elevation of the power line. Next, purpose of this journal. First, utilizing the magnetic field that is on the primary power line and making it a new source of electrical energy. Second, making an equipment that can take the magnetic field plugs into an alternative magnetic power-based field with a voltage of 220 volt to provide electricity to the community near the location. Three, changing people image about the danger of electromagnetic field radiation. Next is a basic theory to understanding in the electromagnetic field technology of electric power line is based on Maxwell laws, Faraday laws, and Joule-Savart law, and several other laws. In figure 1, you can see a conductor rod with current flow in wire. By Maxwell law, if a three current flow in wire will generate magnetic field along the wire with a magnetic field encircling the wire. This electromagnetic field and the curve of density of flux depending on the radius of the circle of electromagnetic field. By Maxwell law, said as simply integrate of the H intensity of the electromagnetic field is equal area integral of the density of current flow in the wire. Next, how to take an electromagnetic field, use toroid that function same as transformer. However, with the primary and secondary coil polarized in a number of turns of copper wire, this coil is used as a secondary winding and two, which is connected to the load. In this case, we use incandescent lamp and electronic lamp. And the electric power line is spaced into the toroid cavity as a primary coil and one which follow which flow primary current I1. As in following picture is the toroid with incandescent lamp as a load. The physical sides of this toroid will determine how much magnetic energy can be taken. The greater the diameter and thickness of the toroid, the more magnetic energy will be taken. Next, if we want to determine how much power the load or lamp can be supplied with voltage V2 equal to rated voltage to 220 volts, then the equal is in equation 12 is P2 asterisk is the name of the capacity power capacity of the load or the lamp, and V2 asterisk is voltage of capacity of load. P2 asterisk is dependent of I1 is current flow in the power line to the light 220 volt. Okay, next is voltage will occur in the lamp or the load depending the I1 is current flow in the power line and depending to where voltage capacity of lamp and capacity power of the lamp P2 as rig. Next, and how to take that method of two experiment 3A and 3B. X is experiment result. For experiment 1 result, see in table 1A in a low current flow and in the core line 27 ampere. For incandescent lamp 5 watt, and voltage occurs in lamp 160 volt. And the condition of the lamp is dim. For incandescent lamp 10 watt, voltage of the lamp is 60 volts, and description of the lamp is very dim. Electronic lamp is 7 watt, and voltage of the lamp is 200 volts, and description the lamp is bright. Next, result of experiment 1B. In table 1B, we can see the medium current of the 80 ampere flow in the power line. For incandescent lamp 10 watt voltage occur the lamp is 230 volts. Description very bright. For incandescent lamp 40 watt voltage occur in the lamps is 225 volts. Description of the lamp is bright. For incandescent lamp 60 watts volt 100 65 volts. Description is dim. For the electronic 15 watt cannot detect the voltage value because the lamp suddenly explodes and goes out. Maybe voltage current will be over greater than 250 volts. And result of experiment 2. In table 2, you can see how to take the lamp, made the lamp and light in the voltage 220 volt for incandescent lamp 40 watts. Use current flow in the power line in 70 amperes. For incandescent lamp 60 watts, current flow in power line is 105 ampere, and incandescent lamp 100, the current flow in power line is 175 amperes. And for electronic lamp 7 watt, and current flow in power line is 30 amperes. Uh, the value of the current in table 2 above is the left excitation current is referred to flow on the wire of electricity to power the light, but then the rate every side of the power of uh, the lamp or the load at the price of normally voltage of uh, 220 volt. It can be analyzed through the characterized curve current wire primary I1 and the rate load voltage VL for some grid and nominal voltage. This is as characterized of um, from experiment in table above. We can see for the incandescent lamp 100 watt is you can see uh, red color and 60 watt in blue color and 40 watt in black color. Now every load, every lamp is um, dependent well use different amber for flowing in the power line. For the 100 watts is about 175 and 60 watt is about 105 amperes and 40 watts is 70 amperes. And conclusion. First, the magnetic field energy along the electric power line can be utilized as alternative electrical energy using toroid. From the analysis through a linear approach, dirt in power lines with large current up to hundreds of amperes can be obtained power up to several kilowatts at 220 volts. The greater the electrical current that flow in the power line, the greater the magnetic field energy around the power line. Second, the more toroid installed along the power line, the more new electrical energy will be obtained. Three, utilizing magnetic field energy in the power line will reduce the public image of the danger of electromagnetic field radiation near the power transmission line. And this is a simulation circuit. We use uh, three sides of the toroid. T1 is the big toroid, T2 is the middle toroid, and middle T3 is small size of toroid. And then, finally, does the paper that I can convey centrally out of Tin, Yakob Itikwatil, Safruddin, Bitu Deviro Ramdhani, Ninik Sri Lestari, Herawati Y.S. Rahmat Hidayat. Sekolah Tinggi Teknologi Mandala Bandung Indonesia, Universitas Kristen Maranatha Bandung Indonesia. Assalamualaikum warahmatullahi wabarakatuh. Peace to all of you. Thank you very much.